Okay, hi everyone. So we are live now, and welcome to this class. And today, following our roadmap, the next thing that is on our roadmap is the operating system. Um, we're going to discuss that in details, and then after that, there's a research project that you have to you have to work on. I think some of you are already doing the research project already. I know that some people have gone through this course ahead of this class, which is really, really impressive. I'm just going to be sharing. I'm not going to be reading in total, right? But the document is for you to go through, read paragraph by paragraph, and then make more sense of it. I'm going to be discussing with you in more technical details and share with you more examples that you can relate with. The word operating system, for short, OS. So it is a crucial software component that acts as an intermediary between the computer hardware and the software applications. So in that being said, it means that we have two types of applications. We have we have the normal application software, and we have the operating system application also too. Now let us look at our normal computer, your normal hardware. Imagine you go to for those of us staying in Ikeja, right? Imagine you go to Computer Village and you say, I want to buy a Windows PC, let's say Dell, for example. No, not even a Windows PC. Let's say you want to buy a Dell PC, right? You cannot say Windows PC except Windows are making their own PC also too. Windows and operating system. So let's say I want to buy a Dell PC, right? And you bought a Dell and you turn it on and it's not coming up, right? It is not coming up. So you're going to be frustrated. You're like, this thing is not working, right? So that means that the hardware is useless to you if you cannot control it. The hardware is useless to you if you cannot operate it. That is where the operating system comes in. Another example is to see like a train and an engine. As long and as mighty as a train is, it is useless without an engine. As big as the ship is, let's take a look at the USS General Ford, one of the most biggest warship in the world right now. Without the rudder, without the I've forgotten, there's an engine that controls that ship. Without that engine, that ship is useless. That is where you see operating system and a machine also to a computer and hardware. So operating system is what makes that guy useful. It is what makes your computer be able to function, right? So it manages and controls the hardware resources also too, such as RAM, central processing unit, which is the CPU, and your memory. So by default, your machine comes with a random access memory. It comes with some nice features like RAM, CPU, and programs. Those are the things that makes it work. For instance, in your engine also too, you have some you have the ignition, you have the alternator and stuff like that. But without the four, it is useless. So that's what operating system is. It is what makes your system tick. It is what makes your hardware useful to you. Now we have types of operating system. Before we go to types of operating system, I'll just take a bit of what is a RAM and the function and the usage, right? So RAM is a type of computer memory. Notice that word, a type of computer memory, but it is used to provide temporary storage. Let me go a little bit further. When you start Microsoft Word, let me use Microsoft Word as an example. When you start Microsoft Word, right? It is the RAM that helps you run start process. So we have two types of memory: the read-only memory, right, which is the ROM, and the random access memory. Now, because when you want to start your application, it needs to come up faster, right? And when you begin to run the application, you will need that RAM to help you, something like a cache. It acts something like a cache. So when your application is running, it fetches information from that RAM. Let me give another example. When you're typing on your Microsoft Word, as you're typing, you are saving. As you're typing, you are saving. While you are saving at that point in time, that guy is being stored on your RAM. Because imagine the fact that your computer has to go to the read-only memory every point in time to fetch information. Your computer will be very, very slow. You get. So while a process is running, while a task is running, at that point in time, they use the RAM to store their to store information or any data. But if any data stored on RAM at that point in time, if the system should go off, that data is what is going to be lost. That's why it's called a temporary data. If you want to persist your data, you must ensure that it gets saved into the RAM, which is the read-only memory, which is what you call hard disk. It's actually hard disk that is being placed in the system, right? So the RAM plays a pivotal role. I'm trying to use examples that you understand better. So it provides fast and temporary storage for data actively used by running programs. Underline this: by data, it provides storage for data actively used by running programs. Example: Microsoft Word, Google Chrome, um what else again, your VLC, you understand, which is your for those that watch movies a lot, which one again, for those that use CorelDRAW, Photoshop, it uses a lot of RAM. That is why if the RAM of your PC is small, like 1 gig RAM, you're not using to run Photoshop, it will look as if you are driving there's this car I want to remember, Ferrari. Imagine driving Ferrari in a mud. Who has done that before? That is how it's going to look like. Imagine trying to drive Ferrari in a mud. That is what it looks like when you're trying to run Adobe Photoshop or Figma in a 1 gig RAM system. You're going to be frustrated. The system I used when I started learning DevOps wasn't not 2 gig RAM, and I was running VirtualBox. So what I do is that when I want to run VirtualBox, I will turn on my system, go back, come back like 30 minutes when the system is stable, turn on VirtualBox, go back for like another 15 minutes again and do other stuff. Then by the time I come back, VirtualBox is fully running. So it takes a lot of time and it was frustrating, but I had no choice. I had to use that kind of system to learn there. But now there are better PCs with higher RAMs that you can purchase to make your life easier. So the usage is RAM is utilized to load and run soft applications. When you start your application, at that point in time, it is the RAM that comes into play, right? To store data for you, and it ensures that your operating system is working as expected. You get. So the next one is the central processing unit. Right. This is the brain of the computer. Right. When they say the brain of the computer, it is where decisions are being made. You understand? It is where decisions are being made. It is what says that, oh, Microsoft Word don't use more than 2 gig RAM. Okay, VirtualBox don't use more than, like, it is the boss. It controls everything. Right. So it is the brain of the computer responsible for executing instructions and performing calculation. It is hardware component that carry out the actual processing of data. It is this guy that actually process your data. When you press 1 plus 1, it is the P that process it and say the answer is 1 or 2, or as the case may be. When you say when you type words, as you are clicking on ASDF column SKJ, right? It is the everything is in 0 and 1. That's another thing you have to know, that the binary the computer understands only binary, which is 0 and 1. So you should see that in that video. Everything you are doing in this computer, these things you are seeing here, everything is 0 and 1. It is the CPU that is what then interpreting those things, processing those data, and giving you something that is readable. Imagine you come into your system and I'm explaining to you 0 1 0 1. You're like, is this guy mad? It is a CPU that helps you to mix that process those data and give something that is readable. When you press AS on your keyboard, it actually goes and is 0 and 1. It is CPU that does those data processing and transformation and execute some tasks and give you, that's how they call it, data manipulation, right? And then gives you um a well represented thing. Also, to when the way I'm moving my cursor like this, the CPU is also doing some things for me also too, right? So as I said earlier, I'm just giving you some technical examples. That video in this project gives you much more detailed explanation. Then the memory, which is the storage. Don't forget, we already said earlier on that if you store things in the RAM, if your system should go down, you're going to lose all the information, right? So it is the RAM that gives us a persistent storage, such that even though you shut down your PC and come back, the data is still going to be there. So it is a non-volatile storage. Yeah, that's a very good word to use. It's a non-volatile storage, and we have the hard disk, which is what we have mostly old PCs, and we have the SSD, solid state drives. Now, there are trade-offs between these two guys. By the time it starts, when you get to AWS, right, and when we're talking about storage, EBS storage, you're going to understand the difference between HDDs and solid state drives, right? While this one is faster than this, right? They are in some cases where you prefer to use HDD than SSDs, right? So by the time you get to that compute area, we want to dive deep on this. As an engineer, for instance, if there are some workloads that you want to spin, right? You should know when to use HDD and SSD. For instance, in AWS, when you want to spin something like a data store to store code data, at this point in time, you don't need to use SSD, right? You will consider things like HDD, and these HDD are of different types also too. But when you need something to compute faster, response faster, right? You want to consider things like solid state drive. So there are reasons why you don't just use HDD or SSD. You get so function memory device. So this function, this memory, it is actually this memory also that stores the operating system. For those that use Windows, when you go to your Windows PC, you used to see that you see in your C drive. If it is 1 terabyte, you notice that some certain megabytes, hundred of megabytes, is being chunked away by default. That's where your operating system is being stored. Let me see if I can show you that in Mac also too. If you come to sorry, let me close this away. If I come to I'm not sure Mac used to show you that kind of this thing. Let me see. I think it should be in settings. So there's always no system preferences. I didn't prepare to show you this. It just popped into my mind. But let's see if I can't. This is why it is a class. Let me see if I can't. I can mess up some things. No, this is not what I want. Something about if this Windows now. See what I'm looking for here. Start objects. So I'm going to use my fingerprints to allow this guy come up. It's taking to time. Yeah, I see. So you got this is my um memory. This is my memory, my hard disk. You call it, most of us call it hard disk. This is not the RAM, right? This is the hard disk, right? And it's called Macintosh HD 12.2. And it is this on this memory that I have my operating system being stored. So if I take out this operating system from my PC and I wipe out the data for the operating system, then the PC is useless, right? The PC is useless. So it is this guy that stores your information, the operating system, because you need it. You cannot store the operating system on the RAM. It's going to be useless, right? And if you want to know what the RAM is, if you come to system preferences for those using Mac, show me the system preferences now. What's your problem? System preferences about system. No, this is not what I want to about this Mac. Okay, sorry. I thought using Windows. So for those using Mac, this is what you see. Oh, this is the RAM, 16 gig RAM. This is where the RAM. This is what we call the RAM, 16 gig RAM, right? But as long as the Windows you are using, you see your core, so you see the processor, and you can the processor is always in gigahertz, 2 gigahertz, 3.3 gigahertz, 4 gigahertz, right? But the memory, this memory you are seeing here is the RAM. Don't forget that memory is of two types, both the RAM, which is a random access memory, which is ephemeral. When I say ephemeral, it means volatile, and the read-only memory, which is the storage, right? Which is non-volatile, where you can keep your stuffs for long, your pictures and stuff like that. For those that like to go to vacation, when you snap, you want to store the picture somewhere. Okay, so this is the RAM that we have here. I'm not sure if this guy used to show CPU and stuff like that. I'm sure there's a way I can check the CPU. So you can see that my own is 8994. This is my own is on 1 terabyte. Sorry, this is 1 terabyte. Okay, but the operating system, all my files here are not up to this is what guy is showing me. Operating system is taking like out of it. I don't have up to 130 gigabyte because if you check what I have here, my documents are very light. Although I have a lot of documents, I have a lot of downloads. I don't have pictures. I don't have videos here. So how come I spend so much here? That means our operating system has taken, if not half, of what I've used here. Let me close this. I should not mess up myself. You get. So I'm just trying to show you what all those things means. You get. Okay. So types of operating system now. We have the single user operating system. We have the multi-user operating system. The single user operating system is designed for a single user at a time, like your Mac OS, your Microsoft Windows, right? Your Ubuntu. Okay. And then multi-user operating system also too. And then we have the real-time operating system. These ones are for smaller machines, right? Things that make things work for. These are the things that the military use. The military does not use in their. For instance, now if you have been to a ship before, right? You see that it has most modern warships now, not ancient warships. Modern warships, they have some a little bit the radar systems, the navigation system, the missile operating systems, right? The control also to have some digital stuff like that. Those kind of applications will not use single user operating system or multi-user operating system. They want to use real time because it has to be fast and it has to be giving information in real time. Because, for instance, a guy in a wrong airspace, if they're about to shoot him down with a missile, if the radar is not telling him on time, the guy will get to heaven before you know that his radar is not working. You get. So it has to happen in a real time. That's why I call it real time operating system. It's very small and fast, right? The embedded operating system, just to add, the real time operating system, let's say for example, is 2 MB. Your operating system here can be like 20 gig or 15 gig. You can see the difference. I'm just making an example. I'm not saying that is the actual size. Again, the embedded operating system are what we use in your TV at home. Some of us have smart TVs, your phones, right? These are what we call operating embedded operating systems, right? If you are familiar with my career, I started with embedded systems in my career, so I'm familiar with things like Arduino, Raspberry Pi, stuff like that. Microcontrollers generally use this embedded operating system. Then the network operating system also to things like Cisco routers. Just it's an operating system, it's an interface, right? But it's mostly used for networking devices, right? And then distributed operating system also too. Yeah. So I forgot to add here, right? But I would like to. I forgot to put in this document, but I would like to talk about it. Um, the history of Unix and Linux, right? So before maybe by Monday, you will see this there. I'll add it. So please just come back and refresh your memory here. It might be in one of these videos also too, but I would like to add it as a document. Unix and Linux, right? So the operating system initially started from it. This is where the issue comes in. Started from the Unix operating system. Then it was, and that was proprietary. So there's one between proprietary software and non-proprietary software. Right? Proprietary software means that it is for commercial use only. It is not meant to be given out for free. It was developed by a set of people, or it's developed by a person, and it's have to keep personal. He doesn't want to share. But if you want it, you have to pay for it. That's what's called proprietary software. So that's where Unix started from. And it was used mostly in mainframe computers then by the militaries, the hospitals, and stuff like that. There were some issues with it that needed, not really issue, but it needed some optimization, right? But there's this guy called Linus Torvald. You read, I'll add it there so that I can have a better. I'm just paraphrasing and telling you, I'm trying to get to a point. So Linus Torvald started working on his own operating system. I was like, okay, since Unix is proprietary, I want to create something that is available for everyone. So the guy was like, operating system should be available for everyone, not just some set of people. So he started working his own operating system, and his name was actually Linux, Linus. So our Linux, as some people will call it. Then he created the operating system, and he called it open source. That's why open source came. Open source means it is free for everyone. People can download it and add and remove to suit themselves. You get. So his own Linux was actually based off Unix. You understand? The Linux operating was a base off or a fork off of the Unix operating system. So modified it, changed some things, and made it free for everyone. You get? So and it's from those that Linux also to Mac based off their own operating system, but they make their own proprietary, right? So it's from that Unix that we now have Windows, we now have Mac, we now have Linux, which is now Linux. You get? But Linux now have different distributions, just like Mac. Mac have OS So, OS Catalina, and some other ones that I don't know. I don't know yet. Different Linux, different Mac distribution. Like Windows also too. We have Windows 8, Windows 10, Windows 11. They don't have different distribution. But Linux have different distribution, just like toothpaste. We have Close Up, we have Dabo, we have Warabi, we have M&K. That one that they used to advertise on our NT white powder like that. So they are all toothpaste, but they are different types. So in the Linux, we have different distributions. We have the Ubuntu, which is we have the Debian, we have the Red Hat, we have SUSE, we have Kali Linux, we have Fedora also too. So don't forget that Linux is an open source and it made it free for everyone. So you can create your own. You can take that project, make some changes, and give it your name. Right now, you can do that today. Download the base project, make some changes. You understand, and call it your own name. So that's why they are different distribution, but they are still called Linux. Do you get? So I'm going to add that to this project also too, so that you understand the different Linux distribution. By the time you start doing virtual machines, which I think is the next thing in the this thing, you're going to see all those things coming into place. You're going to create a VM that has different Linux distributions. You create a VM for Ubuntu, you create a VM for Red Hat, you create a VM for Fedora, you create a VM for Kali Linux. That Kali Linux is what most hackers use, right? Both the good guys and the bad guys. You understand? That Kali Linux is really, really interesting too. I have it, but I don't use it frequently. So you're going to see Red Hat, you see CentOS. So you create virtual machines with these different operating systems and you see how they work. The command you run on Ubuntu will not work on Red Hat. And not all the commands you run on the Red Hat will work on Kali Linux. If you install something on Ubuntu, it might work out of the box. But if you, for instance, now if I install Apache on Ubuntu, I might see the page immediately. But on Red Hat, there are some extra configurations I have to do because Red Hat preaches most they present themselves as more secure operating system than some other operating system, Linux operating system to say. You get? So you will see all these things in actions. You will play with them and understand different things between them. But before that, I'm just going to add the Linux operating system to this thing also to this project so that you can have a good idea. I just hope I'm not mixing things up for you. Hope I'm not confusing you. Do you get what I'm saying?
Yes, yes, we're not confusing us. We understand.
Okay. Okay. Thank you.
Me, I understand. I don't know about other people, but my own.
I speak for yourself. Oh.
Yes, yes. I've corrected myself.
Okay. Okay. If finally Gabriel, hope you're okay, sure. Okay. So that is mostly that about operating system. Please, this course, follow them the way they have been arranged. Right. Try to watch them. See, information is key in your DevOps journey. Information is key. And what we are trying to do is that we are solidifying your base, your foundation. And you will not appreciate this now until you start doing some crazy projects. Do you get? So solidify your base, put in much effort as possible, go through these courses one after the other. Then once you are done, please come to this research project, right? And try to answer this question one after the other. And I think I'm going to pause here for you to entertain questions. Um
Well, this thing you share with us now. Are you going to put it on the channel so that we can go through it?
I think you have access to this operating system or to this project already now.
I don't have access to it too. I'm not sure.
Yeah, I'll post the link. We post the link on the channel again. Don't worry, but you have access to it. I can see you have access.
No problem. No
I'll
problem.
post the link. I'll post the link today. So it is in the folder. Let me share my screen.
Okay.
Yeah,
Okay.
let me share my screen. So if you can see my screen, so there's a folder called operating system. You already have access to this folder onboarding, right? You have
Okay.
access to the operating system. So when I give access to this folder, you have access to these two documents. As I
Okay.
said, all this will go away by the time we have our own website. We'll not be using Google Docs again. But for now, this works fine, and let's
All right.
continue to manage ourselves like that. Yeah.
No problem.
Yeah. So this the recording for this class too is going to be uploaded on YouTube, and then the link will be sent to you alongside the link to this project also too. Questions? Honestly, I really like your feedback. If you like the way the class is going, my explanations, am I talking too fast? Do I explain things to you very well? Or do I teach you something? You go back to the internet and you find out, hey, this guy, what you're saying is rubbish. Oh, you know, these things are important. Like, let me know. Let's talk. Okay.
Okay, yeah, that to me, it's fine. It's
Okay.
going okay. So,
Do you have any
um,
question?
okay, my question, no question for now.
No question for now. Okay, let me pause the recording. I'm going to stop the recording here. So this is the end of today's class operating system, and then we begin next week by God's grace.